Okay, this video is our first in the exponentials unit, and we've talked about a whole bunch of rules of exponents, and hopefully those will kind of come in handy for parts of this video. In this video, we're talking about scientific notation, expressing very large or very small numbers using scientific notation. The purpose for using scientific notation you kind of discovered without really knowing it during the pretest. Because when you were taking the pretest, there was a couple problems on there, like the $100 bill problem, that you couldn't fit on your calculator. And that was frustrating for some of you. So scientific notation is basically a shorthand way of writing very, very large or very small numbers. And it's kind of a sort of abbreviation or shortcut, like sort of like texting language in an analogy for math. I don't know. But anyways, there is a list of things in scientific notation here, and a list of things not in scientific notation over here. Take a look at those two lists, kind of pause the video, see what you notice about this list versus that list, or patterns or things you notice every time over here. Just make a couple observations. Okay, hopefully you noticed a few things. Probably the first was that every single one of these in scientific notation has a 10 to some power. That's the first thing you need to be in scientific notation. So there are two things we need. We need a 10 to an exponent. The second thing we need is this little front part. Well, we need a times. I guess I lied. There's three. We need a times. This first part that goes before the times is a some number between 1 and 10. So we need some number between 1 and 10 times 10 to some exponent. That's what puts something in scientific notation. This one is not in scientific notation because that's not between 1 and 10. This one doesn't have anything close to scientific notation. That's just a really big number. This one, we've got our 10 to the 29, but that's not between 1 and 10. Here we've got a number between 1 and 10, but we don't have a 10 to an exponent. We have a 12 to an exponent. And this one is wrong because 4 squared is actually 16, which is more than 10. So, again, not between 1 and 10. So if we look down here, this first one, we've got our number between 1 and 10. We're trying to classify if this is in scientific notation or not. We've got this number between 1 and 10. We've got 10 to a power of something. This is in scientific notation. The second one, we've got 10 to a power, but that's not between 1 and 10. So this is not in scientific notation because of that 32. This part here, again, has a times 10 to an exponent, but that's not between 1 and 10. So this is not scientific notation. Okay, pretty simple. You just need those two parts. So, an example. Actually, before we get to that, I want to look at these that are in scientific notation right here. The numbers that you see here, how you would expand that back into normal numbers would be to take this 3.4 and multiply it basically by 10 by 10 by 10 by 10 by 10 If you take that and like use a calculator or something, multiply it by 10, by 10, by 10, by 10, by 10, 5 times because of this, you will effectively end up moving this decimal point 1, 2, 3, 4, 5 times, which gives you 3, 4, 0, 0, 0, 0. 340,000. Okay, that's what this number is in normal notation. To do the same with this one, I'm going to take the decimal point and move it 1, 2, 3 times. That's 7, 0, 4, and I had a blank, so add a 0. This one, I'm going to take the decimal and move it 17 times. Okay, you get the idea. To express a very small number in scientific notation, like if I had a 2.5 times 10 to the negative 6. If this were a positive, I'd move the decimal point this way. Because it's a negative, I'm going to move it this way. And that becomes 0.0000025, which is a very small number. Anytime you have a negative exponent, it's a small number. Anytime you have a positive exponent, this is a big number. Okay, so just a little rule for you. I would recommend pausing this and writing this down somewhere, kind of in some empty space or in the margins or a separate sheet of paper or something, because that's a pretty good rule to have down. So once we get to, let's get to this example. Meredith is doing a report on stars and wants an estimate for the total number of stars in the universe. She read that astronomers estimate that there are at least 120 billion galaxies in the universe. An encyclopedia says that the Milky Way, Earth's galaxy, is estimated to contain more than 100 billion stars. Estimate the total number of stars in the universe. Before we can actually do this, we're going to need to make these numbers into scientific notation. So 125 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 125 billion. To change this into scientific notation, my decimal point is over here. I need this decimal point to end up over here so that this number is between 1 and 10. So I take it and I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm looking at 1.25 times 10 to the 11. Now, we moved it left, so it might be a little bit confusing over whether this is positive or negative. This is positive because big numbers have positive exponents. 125 billion is a very, very big number. So this is going to have a positive exponent. Leave that 11 positive. The next one, we have 100 billion. Right now the decimal point is here. I need it to go all the way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm moving it 11 spots, so that's 1 times 10 to the 11th. Again, keep this 11 positive because this is a huge number. If it were a small number, this would be negative, but it's not. So now the question is, what is the total number of stars? Well, from here it's actually pretty easy. We have this many galaxies. Each one has that many stars. Keyword is each, so I'm going to multiply these two things. Now when I multiply these two things, This is actually, if I replace these to make it look a little bit more familiar, this is just a multiplication problem all the way across. So I can use the multiplication property of exponents. 1.25 times 1 is just 1.25 times 10 to the 11th times 10 to the 11th, 11 plus 11 because of multiplication property. 11 plus 11 is 22. So this is 10 to the 22. And that's my answer. All right. Your before class, you have two really big numbers, or two numbers with lots of zeros. I guess this is a really big number. This is a really small number. I need you to take this number, rewrite it in scientific notation. Here's my hint. Take this number, rewrite this in scientific notation. Hint, that's a very small number.